When examining muscular performance, there are several different parameters we can look at. One would be the force or just simply the tension that muscle generates, regardless of if it moves the load. Work, on the other hand, is force times distance. In other words, to generate significant work, we have to actually move the load in question. And then finally, we'll talk about power in another video, and that involves the time over which contraction occurs as well. So let's focus on work for a moment here. Look at graph A. And what we see is that work, remember, equals force times distance. So force on our x-axis here, distance on our y-axis, and work performed in our red trace here. Now, as you can see, at very low loads, right, the force of the load being very small, we can move that load very large distances, right? We can shorten a muscle dramatically when the load is very small. But of course, that means we're multiplying by a very small load or force and generating very little work. On the other extreme, if our load becomes very large and we actually become incapable of actually moving it, we strain very hard, generate a lot of tension, but we don't move it, our work performed would be zero. That's actually what's termed an isometric contraction. And so it's important to note that very strong contractions can generate zero work if the load is not moved. Now finally, we see that optimal work is performed sort of in the middle range here when our loads are, within the range that muscle can move at a significant distance, right? And so both the load is fairly large and the distance we can move that load is fairly large. And we get a very significant measure of work performed here. Let's move over here to B. What we see is we're comparing two different muscles. Again, looking at work, what we want to do is see that a small muscle here in the first part of B, this very small muscle, the relaxed state first, is going to generate very little force. And the reason for that, if we draw a line through it here, remember the cross-sectional area of a muscle cells of that muscle, are a major determinant of how much tension that muscle can generate. So this very small muscle is going to generate low force, right? It just isn't going to have enough cross bridges to generate large force. In addition, because it's a small muscle, it can only shorten a small distance, shown here, this distance moved. And the reason for that is that a small muscle does not have as many sarcomeres in line as a large muscle does, right, within its myofibrils. And remember, each individual sarcomere contributes a certain amount of shortening to the overall muscle. And so a shorter muscle has fewer sarcomeres in series, in line, and therefore shortens a smaller distance and generates little work. A much larger muscle over here has a much larger cross-sectional area, more cross bridges possible, greater tension, right, larger force. And of course, because it has more linear sarcomeres, right, each one shortening some fraction of a micrometer, we get much greater distance shortened. And of course, larger force times longer distance equals much greater work for these larger muscles.